Good evening friends, study with the Pala Engineering and Journal Geology, Parvin Singh book. So in chapter 7, structural feature of rocks, attitude of fault as basis, the mutual relationship of attitudes, dip and strikes of fault and of the disrupted rock has also been used in some cases of classification faults into three types: dip fault, strike fault, and oblique fault. Strike fault. These are the faults that develop parallel to the strike of the strata. In other words, the strike of the fault and that of the disrupted layer are essentially parallel. Sometimes the faults are developed along the bedding planes. In such cases, they are aptly called bedding faults. Dip fault. These are the faults which develop parallel to the dip of the strata. In other words, the fault strike is parallel to the dip of the layer broken and disrupted by the fault. Oblique fault. These are sometimes called diagonal faults. In such a fault, the fault strike make an oblique angle with the strike of the rock in which it has caused the displacement. FS, BS, and this attitude of as basis. So A, B, C diagrams are important. Slip as basis. The directions of slip forms the most important basis for classification the fault into three main types: the dip slip fault, the strike slip fault, and the oblique slip fault. First, the strike slip fault. These have already been defined as those faults in which the net slip is essentially parallel to the strike of the fault, the slip along the dip being almost absent. These are the most important and widely developed faults in the crust of the earth, which have been observed both on the continental and oceanic environment. Eventually, a number of other names depending upon the environment under which these faults have been developed have been specially used for strike slip fault. The following are some of the examples. Wrench fault. It is a strike slip fault in origin in which the fault plane has developed transverse to the regional structure, and even the net slip has also taken place in the same manner. The dip of the fault is very steep, nearly vertical. These are also sometimes referred as a transfer fault. Transform fault. These are strike slip fault occurring in oceanic ridge on an extensive scale. Their importance lies in the fact that it was from the study of development and distribution of transform fault that the theoretical concept of plate tectonic got sound physical evidence. The occurrence of transform fault established the boundaries of oceanic plates in a satisfactory manner. So in this figure, we clearly see tear fault. These are also strike slip fault occurring in the group in continental region that divide an originally extensive block into block of smaller and convenient dimensions that are translated during the process of regional faulting. Some other authors believe them to be similar in nature to the transform fault developing on the continent rather than in the ocean. Dip slip fault. All those faults in which the net slips has taken place parallel to the dip of the fault are classified as dip slip fault. They are often also called normal dip fault in figure. Oblique slip fault. These may be defined as a fault in which the direction of net slip is neither parallel to the dip of the fault nor to the strike of the fault, but is inclined to both these directions. So in figure, dip slip fault and oblique slip fault. Thank you.